awak. Awak yang tu lah. Jangan lupa subscribe channel kita. Tanda sokongan. Terima kasih. Assalamualaikum and hi everyone. So welcome back. Jadi dalam video kali ini kita nak discuss bentuk-bentuk soalan berkaitan dengan subtopik 4.1 iaitu berkaitan dengan work and also the area under the graph of F against S. Okay, so now let's start with the first question. So this is the first question and you can see here we have two graphs of F against S, force against displacement. Okay, so now let's read the question first. A 2 kg object moving with an initial velocity 5 meter per second is acted on by a force of 2 Newton. Okay, so the figure shows the force displacement graph of the above motion. Determine the velocity of the object at 10 meter per second, at 10 meter displacement. Okay, so this is very easy. If we have a graph of F against S, so the area of graph F against S is actually the work done. Okay, so soalan minta kita kira velocity of the object. Okay, so velocity of the object, so we need to find first what is the work done. And we need to use the work energy theorem. So the work done is equal to area under Fs graph. Okay, so here we have trapezium shape. So half times the height is 2. And then the parallel side of the trapezium. So this should be 5 plus 10. Okay, so the work done is actually equal to 15 joule. But if you recall about the work energy theorem, delta K, okay, so we can calculate the velocity, okay, the final velocity here. So given that the initial velocity U is 5 meter per second. So from here, we can relate the equation of W equal to delta K, where W is equal to 15. And this is K final minus K initial. Okay, so here we can find half mv squared. So this is we want to find the velocity, the final velocity, okay, minus half mu squared. Okay, so you can substitute. So we're gonna have 15 half. And then the mass is 2 kg. We can factorize half and m. And then v squared, we want to find v, and u is equal to 5 squared. Okay, so from here, we can find v, and it is equal to, alright, and then the answer is 6.32 meter per second. Okay, alright, so here you must know how to find the work done from area under Fs graph. And second, you must relate W with delta K, and this is under work energy theorem. Okay, alright, so now the second part. So let's read the question. The force F on a body varies with the displacement S from a point O as shown in the graph. Calculate the work done when the body is displaced from S equal to 0 here to here 0.4 meter, and then from 0 to 0.8 meter. Okay, so if you look at the area under the graph for the first part here, okay, this is the area of the graph where the area is positive value. Okay, means that the value of work done, W, okay, when we calculate the area under the graph, it will give you the value of positive, while the second one is negative. Okay, so for the first part, let's say we have the green color here. Okay, we color the triangle here. And then the second one, we use the yellow color. Okay, so for part A, I don't think we have any problem. So we can calculate what is the W1, okay, from 0 to 0.4, okay, meter. So it is half times 0.4, okay, tapak dia 0.4, and then the height is 4, okay, and then the answer is 0.8 joule. Okay, don't forget the unit. Okay, and then B, so we want to calculate from 0 to 0.8, right? So from 0 to 0.8, look at here, we have positive work, and this is negative value of W. Okay, so the work total, okay, is actually W1 plus W2. Okay, so we have calculated just now, W1 is equal to 0.8 joule, but for W2, okay, it is actually half times negative 2 times 0.8 minus 0.4, and it is 0.4. Okay, 0.2. Okay, and then W2 should be equal to negative. Is it negative? Yes, negative 0.4 joule. Okay, and then finally we want to calculate what is the work done, okay, from 0 to 0.8 second. So WT equal to W1 tadi kita dah kira 0.8 plus W2 is negative 0.4. Okay, and then the final answer is 0.4 joule. Okay, unit jangan lupa ya, unit dia adalah joule. So this is answer for part A and this is answer for part B. Okay, so finish question number 1. So let's proceed to question number 2. Alright, question number 2. So let's read the question. So figure 2 shows a 15 kg block being pulled by a 100 Newton force. So this is the force at an initial speed 2 meter per second up an inclined plane. Alright, so the block move at a distance of 6.2 meter parallel to the inclined plane, means that the value of S is in this direction. Okay, so kat sinilah S dia. Okay, from sinilah S dia dah bagi 6.2 meter. Okay, the coefficient of kinetic friction is given. Okay, 0.14. Okay, so we can take out all the informations. So F is equal to 100 Newton, S is equal to 6.2 meter, and mu, okay, mu K is given 1.04. By using work energy theorem, calculate the change in the kinetic energy of the block. So we want to find delta K. Okay, so ini soalan minta kita cari delta K. Okay, so now let's draw the free body diagram of the object on the inclined plane. So I think let's try to draw the inclined plane first. Okay. Okay, boleh lah macam tu. Okay, and then we have an object, okay, which is in this direction, for example. Okay, alright. So now let's sketch the free body diagram. First, we're going to sketch X and Y axis. Okay, so now let's sketch first X and Y axis. Make sure X axis tu on the surface of the inclined plane. Kat mana dia bergerak? Okay, so maknanya dia bergerak kat sini kan? So this is the X axis lah. So kalau you lukis macam ni, dia mesti parallel. Sorry. Okay, macam tu X axis, and then this is Y axis. Okay, and then kat sini kita akan ada apa? Normal force as usual. Okay, you belajar chapter 3. Sorry. Okay, normal, and then weight straightly downward. Okay, so the angle here is given 25 Newton. Sorry, 25 degree. So means that here also 25 degree. Okay, boleh eh? And then the frictional force. Okay, if the object is moving upward, so here we're going to have F, and means that the frictional force must be opposite direction. Okay, so this is 100 Newton. Okay, so we want to calculate W equal to delta K. We want to calculate delta K, but we want to use the work energy theorem where W is equal to delta K. Okay, so untuk cari delta K, kita kena cari total W dia lah. Alright, so now look at this free body diagram. So we have W, and the motion of the object is in this direction. Okay, so sekarang you tengok pada weight. Okay, weight here. Okay, we have W downward, straightly downward. So saya prefer untuk resolve WY and WX. Okay, look at here. So we are going to resolve. Okay, WY straightly downward, and then WX. Okay, so kita akan ada WX, friction, and F. Okay, so the work done, okay, kita nak consider force apa? So tengok pada force that is parallel dengan S, ataupun dia parallel but opposite direction. So for F equal to 100 Newton, it is parallel with S. Okay, tapi untuk friction, and wx, it is parallel but opposite direction. Okay, so maknanya dia on the same surface, okay, on the same x-axis. Okay, so now for w net is equal to, so kita ada 3 tadi kan, capital F, external force, friction, and also wx. So the work done by the external force on the system plus, okay, w friction, okay, the work done to against the frictional force. Kenapa work done to against frictional force? Because the direction of the frictional force is opposite direction dengan motion. Motion dia nak naik ke atas, but direction of the frictional force opposite direction. That means this is the work done, the amount of work done to against the frictional force. Okay, and plus W. Okay, ini apa pula? Okay, ini kita namakan dia sebagai work done. Okay, work done to against the gravitational force. Okay, gravitational force merujuk kepada weight objek tersebut. And this is the work done, okay, to against frictional force. Okay, so let's calculate first. Okay, tapi sebelum tu kita tengok dulu direction. Okay, W, F. So direction of F naik ke atas, S pun bergerak ke sini. So S the same direction. Okay, so the angle between F dengan S nanti equal to 0 degree. But for the frictional force in this direction, sorry. So in this direction, frictional force. Tapi, sekejap saya buat balik semula. Okay, S nak gerak ke atas. Kita nak gerakkan dia naik ke atas. Tapi frictional force opposite direction. So the angle between them is 180. Okay, same goes to WX. S is in this direction, but WX is opposite direction. So angle between WX and S is also 180. So kita akan guna formula work. Okay, work. So Fs cos theta. In this case, F kita adalah F lah. S cos 0 plus, okay, friction. Fs cos 180. Angle between friction and S. And the last one is WX and S, and the angle is 180. Boleh? Okay, so yang ini you tahu, yang ini you tahu dia adalah negative 1. This is negative, 1, negative 1, and negative 1. Okay, so we can substitute all the values. So here we have F, where F is 100 times S 6.2 plus friction. So friction is mu n. Mu n. Friction is equal to mu n. Okay, so kita kena kira lah dulu friction ni. Kita kena kira dulu friction ni. Mu n. Mu dia dah bagi, tapi n ada tak? N normal force you boleh dapat daripada total Fy. Remember, total Fy equal to 0. So in this case, n upward plus, look at here. Okay, the total force in Y component. N is upward, Wy is downward. Okay, so n plus negative Wy. So n kita boleh kira where n is equal to Wy and it is equal to mg cos, this one is mg cos 25. Okay, so kita boleh kira lah friction, where friction is equal to F is equal to mu. Mu is 0.14 times n, normal force, where the normal force is mg cos theta. Okay, mg cos theta. So kita boleh kira lah tu kan. M dia, mass dia adalah berapa mass dia? 15, right? 15 times 9.81. 15 times 9 point, ataupun kita nak kira dulu, bolehlah kita kira dulu. Kita kira dulu dekat sini. Friction. Kan? So tak payah kira kat dalam ni. So nanti friction you nak kira, dia akan jadi 0.14 times mg cos 25. Mass dia adalah 15 times 9.81 times cos 25. So friction dekat sini saya kira saya dapat 18.67 Newton. Okay, 18.67 Newton. So means that you can substitute here 18.67. So 18.67 times S, the displacement is 6.2 times -1, cos 180, right? And then plus WX. So WX is mg sin 25. Mana nak dapat WX? From chapter 3 kita dah belajar kan? Resolve WX dengan WY. Where WY here, okay, WY is equal to W cos 25 and WX is equal to W sin 25. Okay, so plus W, which is mg, okay, mg mass 15 times 9.81 times mg sin 25. Sin 25, okay, and don't forget darab dengan dia punya S displacement tadi 6.2 times -1, cos 180 -1. Okay, cubalah you kira. So this one should be 620 plus -385.58. Okay, plus -115.75. So finally saya dapat jawapan dia adalah 118.67 joule. Okay, so based on the work energy theorem, therefore W net is equal to delta K. So delta K is equal to 118.67 joule. Okay, so this is the answer for question number 2. Alright, so now let's proceed to question number 3, the last one. Alright, question number 3. So a box of mass 40 kg here is pulled by a force F, okay, of magnitude 500 Newton. So here we have a force, okay, where the force F here is given 500 Newton. Okay, and then the angle is 76 degree to the horizontal. Okay, here we have the angle theta. Okay, and it is 76 degree. Okay, on a rough surface means that we have the frictional force as shown in figure 1. Okay, so the kinetic friction force between the box and the plane is given. So here we have the frictional force is 100 Newton. If the box travel 15 meter, so S is 15 meter. So it's moving 15 meter, okay, along the plane. Calculate the work done by constant force and frictional force. So we want to calculate what is the work done by the external force F and the work done by the frictional force F. Okay, so we can use, if you want to sketch the diagram, okay, so here we have two forces, F at angle of 67 degree, and here we're going to have frictional force. Okay, and the object is moving in this direction, which is to the right. Okay, and S is equal to 15 meter. Okay, alright, so number 1, we want to calculate the work done by the external force. So F as cos theta. Okay, so if you want to resolve F, okay, so by definition the work done F as cos theta, so you can resolve F if you want. So let's say you want to resolve F into Fx and Fy. Okay, so antara Fx dan Fy, okay, so kita akan pilih force Fx. Why? Because Fx is same direction dengan S. So angle dia akan kosong lah. So the work done will be maximum if we choose Fx. Okay, tapi kalau you pilih Fy, the angle between Fy and S is 90 degree. So cos 90 degree is equal to 0. Okay, S ke sini, okay, Fy ke sini, atas kan. So it is 90 degree. So tak boleh pilih lah. Cos 90 degree is equal to 0. So kalau you nak resolve, dia akan jadi macam ini. Okay, so Fx, which is F cos 67, and this is, sorry, and S also in this direction. So angle dia kosong. So kalau kita tulis, dia akan jadi WF is equal to force yang kita pilih adalah Fx as cos 0. So this should be 1. Fx kita akan gantikan dengan F cos 67 times S. Okay. Atau kata boleh tak kita nak terus ambil angle antara S dan F? Yes, you can. Okay. So for the second method, you can choose. So F is in this direction and S is in this direction. So the angle between them is 67. Okay. Kalau you tengok dekat sini tadi, kita ambil angle cos 0 because F here, we resolve and then we choose a force that is parallel with S. Okay, so by definition, so the force must be parallel with the displacement. Okay, that's why cos 0. Boleh? So Fx here, kita substitute lah. Okay, kita resolve. And then kita akan dapat F cos 67. Okay, but some of the students, they confused. Dia kata boleh tak nak ambil terus angle between F and S. So kalau you tulis Fs means that angle here is the angle between F and S. So, you akan dapat jawapan yang sama lah. Kalau kita perhatikan, dia akan sama. Okay, so kita substitute. F is 500 Newton. S is 15 cos 67. Okay, so the answer here you have 1814.41 Joule. Okay. Tapi kalau you guna tadi pun sama jugalah. You akan dapat F is 500 cos 67 times 6.2. Times 15. So you akan dapat jawapan yang sama. 1814.41 Joule. Okay. Alright. And then you want to calculate what is the work done by the frictional force. Okay. So Fs, angle antara friction dengan S, obviously 180 degree. Okay. So, dia nak gerak ke sini S. Tapi friction opposite direction. So, 180. Okay. So, you akan dapat nilai dia adalah, friction dia dah bagi tadi, berapa? 100. S is 15. And cos 180 is negative 1. So, you akan dapat negative 150 Joule. Okay, so remember, negative means that the work done, okay, by the system to against the frictional force. Okay, negative 150 Joule. Okay, the total work done ataupun you boleh tulis sebagai W net is actually equal to the work done on the system by the external force plus the work done by the system to against the frictional force. Okay, so 1814.41 Joule plus friction is negative 150. Okay, so you akan dapat jawapan lah 314.41 Joule. Okay, so this is the answer. Alright, so finish for this video. Alright, so for the next video, don't forget to follow the lesson since I will discuss all the questions related to the conservation of energy, okay, yang berkaitan dengan spring sahaja. Alright, so see you in the next video. Assalamualaikum. Bye-bye.